In this video, let us solve more problems based on surface areas and volumes of combinations of solids. And we've got a problem here which reads this way. I think it's got to do with an ice cream. So let's see what it is. A right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. The ice cream is to be filled in cones of height 12 centimeter and diameter. Don't be confused about the right circular cylinder. We don't have that here. The question is, there is some ice cream already in the right circular cylinder, and that has to be filled in the cones of height 12 centimeters and diameter 6 centimeters. Diameter is 6 centimeters, so the radius is going to be 3 centimeters, having a hemispherical shape at the top. Find the number of such cones which can be filled with ice cream. Okay, it seems like there's a lot of ice cream in this right circular cylinder, and you have to take all this ice cream and fill it in these cones of the given measurements. So, how many cones is it going to take to fill all the ice creams that is there in the right circular cylinder? So what we have to do is it seems like we need to find the volume of the right circular cylinder, and that's the amount of ice cream that's going to be there. And then find the volume of this cone. Not only this cone, also this, this hemispherical thing here, because it's not going to be up to the brim. It's going to be more than that, and so much. So there is going to be so much volume of ice cream. So once you find the volume of the right circular cylinder, and once you find the volume of this shape, divide the volume of the right circular cylinder by the volume of this one, which is going to give you the number of cones that is going to take to fill the ice cream that is present in the right circular cylinder. Well, that's the way we are going to solve the problem. Now let us go do that. So what we have here is the radius of the cylinder is 6 centimeters, because the diameter is 12 centimeters, right? So the radius is given as 6 centimeters. The height of the cylinder is 15 centimeters. First of all, let us find the volume of the cylinder. The volume of the cylinder is pi r square h, right? So let us substitute pi times r square is nothing but 6 square, because the radius is 6 centimeters, the diameter is 12, the radius is half of the diameter. Then we've got the height is 15 centimeters, so multiplied by 15. So this is nothing but 15 times 6, that is 90. 90 times 6 is 540. 540 times pi is 540 pi. Since the volume is going to be in centimeter cube, right? So we've got 540 pi centimeter cube. Let us find the volume of the ice cream cone. So let us move to the cone. The radius of the ice cream cone is 3 centimeters. The height of the ice cream cone is 12 centimeters. So now let us find the conical part. Let's find the volume of the conical part of the ice cream, because the ice cream also comes out of the cone and, presents itself in the form of a hemisphere. So, I'm sure you know that because we've all eaten ice creams in cones. So let's first find the volume of the conical part of the ice cream. So here we are. So volume of the conical part of ice cream. How do you find it? The volume of the cone is 1 by 3 pi r square h. So it's going to be 1 by 3 times pi times r is 3 centimeters. So r square is 3 square times h. H is the height, which is 12 centimeters, equals, there are 2 3's here, so 1 3 and 1 3 is going to get cancelled. The remaining is 36. 12 times 3 is 36. 36 pi centimeter cube. So this is the volume of the conical part. Now let us find the volume of the hemispherical part, right? Yeah. So volume of, I'll just write it volume of hemisphere here, but actually it is the volume of the hemispherical top of the ice cream cone. The volume of the hemisphere is given as 2 by 3 pi r cube. So that's going to be 2 by 3 times pi times, the r is again 3 here, you can see it. So it's 3 cubed because it's r cubed. And that's going to take away a 1 3. So it's going to be left with 2 3's. So 3 times 3 is 9. 9 times 2 is 18. So that is giving us 18 pi centimeter cube, right? So now, what is the total volume of ice cream here? Let's find that. Total volume of ice cream, that is including the ice cream in the cone and as well as the hemispherical part, is nothing but 36 pi centimeter cube plus 18 pi centimeter cube. right? So this is going to be 54 pi centimeter cube. The reason I haven't substituted the value of pi and, saving us the trouble of calculating it is because eventually you have to divide the volume of the cylinder by the volume of the ice cream, because we need to find the total number of cones. So pi and pi will get cancelled. So therefore, the number of ice cream cones equals volume of the cylinder divided by the total volume of ice cream in each cone. Of course, it also includes the hemispherical part, so don't wonder about that. So this is going to be, the volume of the cylinder is 540 pi centimeter cube divided by the volume of the ice cream in one cone including the hemisphere is 54 pi centimeter cube, and the pi gets cancelled. 54 goes 10 times in 540. Therefore, you need 10 cones to fill the ice cream that is present in the right circular cylinder. Pretty simple problem again. All you had to do was, there were different shapes here, a hemisphere and a cone. If you could find the volumes of cone separately and hemisphere separately, I'm sure you could have done this as well. There was also a right circular cylinder in there in the start. So, we got to find 3 different volumes, and we had to add one hemisphere's volume and one cone's volume, and, divide the volume of the cylinder by that to get the number of cones that was needed to fill the ice cream that was present in the right circular cylinder. So that's all that there is to do. Now, very complex, a very straightforward, simple problem. So this ends this video. I'll see you in the forthcoming videos with more problems based on surface areas and volumes of combinations of solids.